Isotones are a type of atomic species that are defined as atoms with the same number of neutrons but different numbers of protons. In other words, isotones have the same neutron number but different atomic numbers, and therefore belong to different chemical elements. The concept of isotones was first introduced in the early 20th century as part of efforts to better understand the structure of atomic nuclei. At the time, scientists were studying the behavior of atomic nuclei using various techniques, including mass spectrometry and nuclear reactions. One of the key findings of this research was that atoms with the same neutron number but different atomic numbers could have vastly different properties. For example, isotopes with more protons tend to be more stable than those with fewer protons, and isotopes with odd numbers of protons or neutrons tend to be less stable than those with even numbers. Isotones are important in a variety of fields, including nuclear physics, nuclear chemistry, and nuclear engineering. They can be used in a wide range of applications, from energy production to medical imaging to materials science. One of the most important applications of isotones is in nuclear reactions. Because isotones have the same neutron number, they can often be used interchangeably in nuclear reactions, allowing scientists to create new isotopes or elements by combining isotones from different elements. Isotones can also be used as radioactive tracers in medical imaging. By injecting a small amount of a radioactive isotope into the body, doctors can track the movement of the isotope through the body using specialized detectors. This technique is often used in diagnostic imaging to detect the presence of diseases or to monitor the effectiveness of treatments. In addition, isotones are important in materials science, where they can be used to create new materials with specific properties. For example, scientists can use isotones to create alloys with specific magnetic or thermal properties, or to develop new materials for use in nuclear reactors or other high-stress environments. Overall, isotones are a fascinating and important concept in atomic physics and chemistry. By understanding the properties of isotones, scientists can gain new insights into the behavior of atomic nuclei and develop new technologies and applications with a wide range of practical uses. The concept of isotones was first proposed by the British physicist Frederick Soddy in 1913. Soddy was working on understanding the nature of atomic structure and the behavior of radioactive elements. He noticed that some elements with the same atomic mass had different atomic numbers and therefore different chemical properties. He realized that these elements had the same number of neutrons but different numbers of protons, and he coined the term isotone to describe this new type of atomic species. At the time, the idea of isotones was a significant breakthrough in nuclear physics and chemistry, and it helped to lay the groundwork for further research into the behavior of atomic nuclei. Over the following decades, scientists continued to study isotones using a variety of experimental techniques, including mass spectrometry and nuclear reactions. One of the key findings of this research was that isotones with more protons tend to be more stable than those with fewer protons, and that isotones with odd numbers of protons or neutrons tend to be less stable than those with even numbers. This is because atoms with more protons have a stronger electromagnetic force holding their nucleus together, while atoms with odd numbers of protons or neutrons have an unpaired particle that can destabilize the nucleus. Scientists also found that isotones could be used in nuclear reactions to create new isotopes or elements. By bombarding a target material with isotones of a different element, scientists could create new isotopes that did not exist naturally. This technique has been used to create a wide range of isotopes for use in nuclear medicine, scientific research, and industrial applications. Today, the study of isotones is an active area of research in nuclear physics, chemistry, and engineering. Scientists are continuing to develop new techniques for studying the behavior of atomic nuclei and for creating new isotopes with specific properties. The study of isotones has led to a deeper understanding of the nature of matter and the forces that govern the behavior of atomic nuclei, and it has opened up new avenues for research and technological innovation. Isotones share a number of important characteristics, which help to distinguish them from other types of atomic species. Same neutron number. Isotones have the same number of neutrons, but different numbers of protons. This means that they belong to different chemical elements but have similar nuclear properties. Different atomic number. Because isotones have different numbers of protons, they have different atomic numbers and belong to different elements. This means that isotones have different chemical properties, even though they have the same neutron number. Varying stability. The stability of isotones can vary widely depending on the number of protons they contain. Generally, isotones with more protons are more stable than those with fewer protons, and isotones with odd numbers of protons or neutrons tend to be less stable than those with even numbers. Nuclear reactions. Isotones can be used in nuclear reactions to create new isotopes or elements. By bombarding a target material with isotones of a different element, scientists can create new isotopes that do not exist naturally. Applications. Isotones have a wide range of applications in fields such as nuclear medicine, scientific research, and industrial applications. They can be used as radioactive tracers in medical imaging, as fuel in nuclear reactors, and as a source of radiation in scientific experiments. Atomic mass. Isotones may have different atomic masses depending on the number of protons they contain. This means that they may have different physical properties, such as density and melting point, compared to other isotones with the same neutron number. Overall, the characteristics of isotones make them an important and versatile type of atomic species. By understanding their properties and behavior, scientists can gain new insights into the nature of matter and develop new technologies with a wide range of practical applications. Isotopes, isobars, and isotones are three types of atomic species that have different numbers of protons, neutrons, and electrons. Here are the key differences between them. Isotopes. Isotopes are atoms of the same element that have the same number of protons but different numbers of neutrons. This means that isotopes have the same atomic number but different atomic masses. Isotopes have similar chemical properties but different physical properties. They may have different isotopic abundances in nature, and some isotopes may be radioactive. Isobars. Isobars are atoms that have the same atomic mass but different atomic numbers. This means that they belong to different elements. Isobars have different chemical properties because they have different numbers of protons and electrons. They may have different isotopic abundances in nature. Isotones. Isotones are atoms that have the same number of neutrons but different numbers of protons. This means that they belong to different elements but have similar nuclear properties. Isotones have different atomic masses and different chemical properties because they have different numbers of protons and electrons. They may have different isotopic abundances in nature. In summary, isotopes, isobars, and isotones are three types of atomic species that differ in their numbers of protons, neutrons, and electrons. Understanding the differences between these types of atoms is important in fields such as nuclear physics, chemistry, and materials science. Isotones share the same number of neutrons but have different numbers of protons, which means they have different physical and chemical properties from each other. Some of the physical and chemical properties of isotones are: physical properties. Atomic mass. Isotones have different atomic masses from each other because they have different numbers of protons. This means that isotones may have different densities, melting points, and boiling points. Radioactivity. Some isotones are radioactive, which means that they emit radiation as they decay over time. The rate of decay, or half-life, of radioactive isotones can vary widely. Nuclear binding energy. Isotones may have different nuclear binding energies, which reflect the amount of energy required to hold the nucleus together. Isotones with higher nuclear binding energies tend to be more stable than those with lower nuclear binding energies. Chemical properties. Chemical reactivity. Isotones have different numbers of protons, which means they have different numbers of electrons in their outer shells. This affects their chemical reactivity, or their ability to form chemical bonds with other elements. Valence electrons, the number of valence electrons, or electrons in the outermost shell, varies between isotones. This affects their ability to participate in chemical reactions. Ionization energy. Isotones have different ionization energies, which reflect the amount of energy required to remove an electron from the atom. This can affect their chemical behavior and reactivity. In summary, isotones share the same number of neutrons but have different numbers of protons, which leads to different physical and chemical properties. Understanding these properties is important in fields such as nuclear physics, chemistry, and engineering, as well as in applications such as nuclear medicine and scientific research.